Hello everyone and welcome to the lecture on creating a simple smart contract using Remix IDE or Remix Integrated Development Environment. So in this lecture, we will do 4 steps. The first step, we will create a contract file. And then the second step, we will define the Spdx license identifier. And then in the third step, we will specify the version of Solidity with the pragma keyword. And then in the fourth step, we will start writing the simple smart contract using the Solidity strong type programming language. Okay, now we will go to the Remix Online Editor and start creating the contract file. We will click on the File Explorer menu and then select or open the contracts folder. So the new file will be saved in this folder. And then click on Create a New File. And then we will name the file as simplebank.sol. So after we have created the file, now we need to define the Spdx license identifier on the very top of Solidity file. So I recommend you to learn the information of Spdx license identifier on the Solidity official site. Okay, let's specify the version of Solidity with the pragma keyword. So in here we are using the pragma keyword and then the Solidity keyword and then the Solidity version is higher or equal than 0.7 and lower than 0.9. The pragma keyword is used to specify the new version of Solidity. So if you use the syntax or features that exist on the new version of Solidity, then you need to specify the correct Solidity version. The second one, the pragma keyword is also used to specify the Solidity compiler that allows it to compile this Solidity file. So it means that we need to compile this Solidity file, then we need to choose the Solidity compiler version that at least version 7 and lower than version 9. Okay, let's choose the Solidity compiler lower than version 7 to compile this Solidity file. And then it will automatically undo that action and select the correct or right compatible version of the Solidity compiler. And this automation selecting the right compiler will also prevent the breaking of the new Solidity features that cannot be compiled with the oldest version of Solidity compiler. Okay, now we will start writing the simple smart contract using the Solidity strong type or high-level programming language. The smart contract always starts with the contract keyword and then followed by the contract name, and we will name same as the file name on here, Simple Bank. Then followed by the open and close curly braces, and all the members of the contract will inside this open and close curly braces. The Remix comes with 3 default contract files, storage, owner, and ballot. And we see on the storage file, the contract is the same as the file name. This naming standard is also being applied on the owner file and then the ballot file. They just prefix the file name with the number 1, 2, 3. So it makes everyone easier to scan the total file creation on the contracts folder without need to count it. Now we will implement the very small or basic part of the programming language such as variables in your smart contract. So in the first line of code, we will define the variable to store the data. But in Solidity, we call it as storage or state variable. Because the Solidity is a strong type programming language, then we always need to define the data type of the variable in the very beginning of the variable. And then in the second code, we will define the visibility of the variable. So if you learn the OOP or object-oriented programming, then you don't feel strings anymore with the public, private, and internal keyword. So if not yet, just don't worry because we will learn all these rules in the Solidity section. And in the third word should be the variable name. So the uninteger will represent the data type. Then the public keyword will represent the variable visibility, and then the deposit will represent the variable name, and close it with a semicolon. So I will copy all this code inside your smart contract. Okay, now we will create and implement a function constructor in the second line of your smart contract code. So the function constructor is a special and optional function that can be declared using the constructor keyword. And then followed by open and run bracket. And then followed again by open and close curly braces. And all the constructor code will be inside this open and close curly braces. And this function is mainly used to initialize the state variables of a contract. So the code inside this constructor function will be executed when the contract is deployed on the blockchain network. So we will add or initialize the deposit inside these functions. Deposit is equal to 2000 and close it with a semicolon. And now we try to deploy the contract. And we will check the value of the deposit. Okay, the value is 2000. So when we define the variable, the value is 0, and then adding the 2000 inside the constructor function. So this proves to us when the contract is deployed, the function constructor is executed or initialized. Okay, now we will just create and implement a very simple function in your smart contract. So how the function works in Solidity is almost the same as the function in any programming language. So if you learn other programming language before, then it will be so easy for you to write the function in Solidity. If not, then just don't worry, because we will learn the function completely in the Solidity section. To create a function, then it should be started with a function keyword and followed by the function name, and then followed by an open and close round bracket. So inside this open and close round bracket, we can insert the function argument. And this function argument will make the function more dynamic and can receive data from outside and then process the data inside the function. And then followed by function visibility, then followed by open and close curly braces. So all the function code will be inside this open and close curly braces. Because the function name is saving, so the code inside the function should be adding or increasing the value. So inside this function, we will increase the value of the deposit by adding the deposit current value with the new deposit value that is being received from the function argument. Okay, now I will copy all the function code inside your smart contract. Okay everyone, we just create a very simple smart contract and we are taking a short break, and I will see you in the next lecture.